All right, so we're going to do a lab here with hot and cold water, and thus the name, the hot and cold water lab. So what I've got going on is I've got a small cup, and I'm going to put it on the balance. My balance was zeroed before I used it, and the mass we're going to call 2.11 grams. And I'm going to now take this small cup and I'm going to fill it with some water, about half full. It doesn't really matter how full I fill it. I would just need it about half full. So there we go. Here's why it didn't matter how much I put in, because I'm going to measure exactly how much it is now weighing. 83.15 grams. So 83.15 grams. Now note that's not the mass of the water, that's the mass of the cup and water. You'll have to do subtraction later. And then we're going to find the temperature of this cold water. Now, contrary to popular belief, no one chills the water coming out of your faucet. We call it cold water because it is not hot. It is likely going to be room temperature because all the pipes run through the same building as the room is in. And so I'm not surprised, and I'm not letting go of this. See this, okay? You never want to let go of your thermometer. It'll tip the cup over. I'm not surprised my thermometer is really not changing. Let's see how good a close-up we can get. Very good. We're going to go the 10th place, so 22.0 degrees Celsius, which is pretty normal for our classrooms here. 22.0 degrees Celsius. All right, now I have a large cup, and I'm going to find the mass of the large cup, 4.16. grams. Now I'm going to fill the large cup with hot water. So I have my hot water dispenser here. I don't know if you can see the steam coming off of it. It is hot. That's about half full. So I'm going to take it over. And I'm going to put my hot water right there. And now I'm 171.2. Okay, do you notice what's happening? Yeah, it's losing mass. Why would it be losing mass? Well, you should be able to figure out why it's losing mass out of the cup. We're gonna call that 171 because we gotta have a number. So 171.00 grams. All right. And we want the temperature of the hot water. Okay, so I'm going to stick the thermometer and I'm going to move it to the counter, a little more stable. I'm going to stick the thermometer in, and now that liquid is moving. You can literally see it moving there before your eyes. I'm going to stir it just gently here. Waiting for it to stop moving. It looks like it is still moving. Giving it a stir here. I know, isn't measuring temperature fun? It looks like it may have stopped moving. Doing some gentle stirring to be sure. Yeah, it has not changed. Looking good. So I am not quite at 77. So I'm going to, and I'm not leaving my thermometer in my cup. No. I'm putting it on the counter where it won't roll and it won't tip the cup over. And I'm not quite at 77. So I'm going to call this 76.8 degrees Celsius. That's what I feel that is. Okay, so here's what you're going to do. You're going to use this information to fill in this quick little chart here. All right, I made a little summary chart here for you to fill in. This is the very necessary information you need, so you're going to use those numbers to fill this in. And then we do some fun math. See, here's the thing. When I mix the hot into the cold, okay, the cold is going to gain heat, and the hot is going to lose heat, and that's why there's a little negative there, because that's the sign for losing heat. And remember, heat and temperature aren't the same. What is heat? Heat is the mass times the specific heat times the temperature change. Now here's the thing, they're going to come to the same final temperature. See this TF here and this TF here? That's going to be the same. So that's actually what I'm solving for. That is what I want to isolate in this whole equation. I know it's not going to be fun looking. We're going to have some fun math time here, but in this whole equation, we're looking for that temperature final. Well, okay, so I tried to help you out here, and I did all the rearrangement you would need, and since we're working with water, the specific heat's canceled, because it's the same 4.18 in each of those, okay? What hasn't canceled, I have different masses and I have different initial temperatures, and we're looking for the final temperature. So this is the math you're going to do. So in this space here, I want you to do the math, all right? And you are literally going to calculate a prediction for the temperature of the resulting mixture. And so you'll get a degree Celsius. We're looking for a final temperature. All right. So pause the video, do that, take the time you need to get a temperature. Now let's discuss reasonability here. What would be a reasonable answer? Well, my cold water started at 22 and I expect it to warm up. And my hot water started at almost 77 and I expected it to cool down. So my answer here should be between those two. So you have a good idea if your answers are going to be close between 22 and 77. Now here's the thing. Please note, I used about 80 grams of cold water and I'm using about 165 grams of hot water. I have way more hot water than cold water. So what do I expect? I expect the temperatures between 22 and 77, your answer, whatever you get here. What I also expect is it's going to be slightly towards the warmer side. It's not going to be in the middle of 22 and 77. It's going to be a little warmer than that because of the fact I have more hot water than I have cold water. Okay, so do this, pause the video, do this calculation. You got to do all this first and then come back and I'll give you this and you can finish up that. So here we go. You should have paused the video. I'm going to mix them. You should have done your calculation first. Don't be continuing until you've done your calculation. So I'm going to mix them. So I'm expecting my hot water is going to, here we go. My hot water is going to be hot. I should pour the other way. And my cold water is going to, wow, my hot water is going to get cold and my cold water is going to get hot. That's what I'm trying to say. And I'm stirring gently, very gently, because I poured in the wrong direction, but that's all right. Okay. I'm going to get, oh look, I am in between. I am definitely going to be in between 22 and 77 here. And it looks like the temperature is still moving. Right now I'm about 53. I'm going to give it a nice gentle, super gentle stir. Here we go, super gentle stir. And it looks like I'm still really, I may even be already moving down, which is good news. That means I reached my highest. My highest just barely was slightly less than 53. Is what I'm seeing there. And again, look, I'm putting my thermometer down so it doesn't roll away and doesn't tip my cup over. Okay, so down here, I'm not going to go 53. I'm going to call that 52.7 degrees Celsius is what I measured there. Okay, so now you have all the numbers you need. You should have already done all the calculations. You really ought to just only have this question left to answer and then turn in. Let me point out, I italicize and underline it. I mean this, you will lose points if you don't do that, so be careful. Good luck.